Then to find the total differential, we use the formula dz is equal to partial of f with respect to x, then multiplying the x plus partial of f with respect to y, multiplying the y. In this video, we learn about differentials. Given a function z which is equal to f of xy, then we define the differential of z to be dz is equal to the partial of f with respect to x multiplying the x plus the partial of f with respect to y multiplying the y. This is also referred to as total differential. And so differential is the same as total differential. Example 1. Find the total differential of f of xy, and f of xy is defined to be y multiplying ex plus sine of x. Solution. The total differential dz is giving us partial of f with respect to x multiplying the x plus the partial of f with respect to y multiplying the y. And so we must first compute partial of f with respect to x and partial of f with respect to y. Now partial of f with respect to x is giving us, and so we have to differentiate this guy with respect to x. So we are going to treat all y as constants, right? So here we have y ex, so we just have to differentiate ex. So differentiating ex is just ex, so we are going to have y ex. Then we now differentiate the second term. So when you differentiate sine of x, we are going to have cosine of x. So that's going to give us plus cosine of x. Then let's compute partial of f with respect to y. Thus, we need to differentiate this guy with respect to y. So we are going to treat all x as constants. So here, this guy will go to 0 since this is a function of x alone. So we just have to differentiate y ex. So when you differentiate y with respect to y, you're going to have 1. So that will be 1 times ex, which will be ex. And so partial of f with respect to y will just be ex. Now let's compute our total differential. So here we have partial of f with respect to y and partial of f with respect to x. So the total differential dz will be giving us partial of f with respect to x, and that's y ex plus cosine of x. So we're going to have y ex cosine of x, then multiplying the x. So this will be the x, then plus partial of f with respect to y is giving us ex, then multiplying the y. Hence, our total differential is given below. Example 2. Find the total differential of f of xy giving us the square root of x plus y. Solution. Here we have f of xy giving us the square root of x plus y. So we need to rewrite f of xy. So we can rewrite the square root as exponent 1/2. So that will be x plus y, all exponents 1/2. Then to find the total differential, we use the formula dz is equal to partial of f with respect to x, then multiplying the x plus partial of f with respect to y multiplying the y. Let's compute partial of f with respect to x, which is equal to del f del x. So we need to differentiate this guy with respect to x, right? So here we are going to use the chain rule in addition to partial differentiation. So we move the exponents down. So that will be 1/2 down. You subtract 1 from the exponent. So that will be minus 1/2. Then you differentiate what's inside. So when you differentiate x plus y with respect to x, you're going to have 1 since y is now a constant, so it will go to 0. So this guy will be multiplying y. So simplifying this, we are going to have 1/2, then x plus y, all exponents 1/2, which is equal to 1 divided by 2 square root of x plus y. Because since the exponent is minus, we can rewrite it in this way. We now compute partial of f with respect to y, so that's del f del y. So we need to differentiate this guy with respect to y, so we use the same idea. We use the chain rule. So you move the exponent down, you decrease it by 1, then you differentiate what's inside. So we are going to have 1/2 x plus y, all exponents minus 1/2. When you differentiate this guy with respect to y, you're going to have 1. So this will be multiplying 1. Simplifying this as we did for partial of f with respect to x, we are going to have 1 on 2 square roots of x plus y. And so the total differential, the z, will be giving us, so here you have partial of f with respect to x, and that's what we have in here. So that will be 1/2, then square root of x plus y, multiplying the x, plus partial of f with respect to y, and that's what we have in here. So that will be 1 on 2 square root of x plus y, multiplying the y. And thus our total differential is given below. Thank you for watching. See you in the next video.